This is My Math Lab number 20 from Online Homework 3 and Math 103, Introduction to Calculus. And it is an application of the Intermediate Value Theorem. We know it as if you have some value A who is below when you plug it in, and some below the x-axis, and some value B who, when you plug it in, is above the x-axis, or vice versa, then your function being continuous means you must go through the x-axis. It's not just about having some value C in the interval AB such that f of C is equal to 0. Technically, what the Intermediate Value Theorem says is that not just 0, but all values in between f of B and f of A must be attained at least once. And so this question has us looking closely at that. We have the value E, which is about 2.71. 718, and then it goes on forever and doesn't repeat and doesn't end. And so this is going to play the role of the 0 here. So it's our job to, over here it was f of A less than 0 who's less than f of B, but that can be the other way too, where we have f of A greater than 0 who's greater than f of B. And so playing the role of 0 is E. And what we need to happen is that we need an A and a B, such that when we plug them in, we have E in between them, either the A being smaller or the A being bigger. And so visually, we have this Y and X axis, but then here's E, and we are looking for an x1 and an x2 such that the f of x1 is less than E and the f of x2 is more than E. Therefore, you can't have a continuous function who doesn't go through E, or vice versa, where we could have the f of x1 being above and the f of x2 being below. And so that's why the answer to the first part is A. We're looking for E to be in between these Y values, f of A and f of B. So then they have us trial and error, picking some x's. The function is x cubed minus 3x plus 5. So take a negative 3 and cube it, and then take away 3 times a negative 3 and add on 5. That'll be a negative 27 plus a 9 plus a 5, 14 positive, and negative 27, that's going to be a negative 13. When we plug a negative 2 in and cube it, what we end up with is a negative 8, but then we add on 6 and add on 5. So that's adding on 11, and that'll give you 3. Now, E, remember, is 2.71, and we just found the fact that negative 3 gives us a negative 13, and we found that negative 2 gives us a 3. So somewhere between negative 3 and 2, because this is a continuous function, polynomials are continuous everywhere. There's no break in the graph of a polynomial. You must at least go through and have some place where you have to cross over. In between negative 3 and negative 2, you must have some place where you have to cross over E. And so does a solution exist between negative 3 and negative 2 for f of x equal to E? our answer is yes. And the reasoning is because the f of negative 3 was smaller than, this was a negative 13, and the f of negative 2 was it 3? Yeah, it was 3. So E falls in between those. So by the intermediate value theorem, we're guaranteed that somewhere between negative 2 and negative 3, you can plug that into your function and get an E out. Okay, so A for the first one, negative 13, 3, and now the second answer here. Now that we continue on with the next two. And remember these values, because we'll need them on the next one. See, root 3 is about 1.71, and so negative root 3 then is going to be negative 1.71. And now remember, f of negative 3 was negative 13, and f of negative 2 was 3. And yeah, negative 1.71 falls in between these values. So there is a value for which we don't know what the value is or how to find it, but when you plug it into our function, a negative root 3 will come out. And so we're going to put in the fact that f of negative 3 is less than negative root 3, which is less than f of negative 2. Not this one. This is going the wrong direction. The B is going the wrong direction. So it must be C. Now in part C, we're looking at 7 million. With the number so large, it's definitely going to have to use a calculator. They tell us to start with the large x value, 185, and they want us to plug it into our function. Remember, the function is f of x is x cubed minus 3x plus 5. So they want us to take 185 and plug it in. So we'll definitely use a calculator. Here I am on a TI-83, and I'll put the function in y1, and now I can go back to the home screen and get y1 on the screen and be able to immediately plug in whatever number I want. So this number here, 6,331,075 is what you get when you plug in 185. Plug in 190 and you get 6,858,435. Now we're aiming for 7 million, but the way the intermediate value theorem works is that we're going to need to have something, 7 million fit in between these values, and it doesn't. 7 million is not in between these two values, so we can't say that there's a solution exists between these two values. And so we come back with the response that no, it's in, does a solution exist? We say inconclusive, because 7 million doesn't lie between our two y values. Okay, and then they tell you that, well, let's just take another one. So they tell you, let's take 195, go to the calculator, and that'll give me 7,414,295. And so remember that the 190 gave 6,858,435. Wow, when we plug in 195, we get the 7 million number, 414,295. So 7 million is in between the f of 190 and the f of 195. So yes, there's a solution. We don't know where it's at, but somewhere between 190 and 195, when you plug it into your function, you'll get 7 million out. And graphically again, imagine this is 7 million. And we down here at 180, we were below. 190, we were below. But when we go to 195, we're above. So we have to somewhere in between. We don't know where, but there is a C somewhere that'll make us be exactly equal to 7 million. And that's it. That's how that works. It's an intermediate value theorem, not just applied to find roots, but using the full statement of the theorem, every value in between the y values can be obtained so long as your function is continuous. That's the key. Got to start with a continuous function. All right, great.